Hey everyone, welcome back to my YouTube channel. If you are seeing it for the first time, this is Santosh Pothraju. Today we are in a Kafka tutorial playlist. If you missed the earlier videos, I highly recommend start watching from the beginning of the video series. And today we are going to talk about what is the Kafka architecture and messages flow. If you are interested in only this topic, I would recommend you can continue watching this video. With that said, let's start up with our video. So as we know, in the earlier videos, we already spoke about what is the content of this video series. We already gone through introduction overview, and we also gone through the Kafka terminology with the one practical example. So in this video, we are going to talk about what is the Kafka broker architecture and messages flow. So as you know, most of the times we will try to explain all these concepts with the whiteboard. So like previous videos, we are going to take a look at what is the Kafka architecture in our whiteboard today. So let's split our screen into two parts, and here there are two different type of architectures we have to understand very clearly. One is a single node architecture, and the second one is multi-node architecture. So in the single node, like the name is describing, so basically here we are going to have only one single server, and within this single server we are going to have Kafka service. And on other side we are going to have one complete cluster, and within this cluster we are going to have more than one server. For example, let's consider we have 3 servers in this particular cluster. As we already gone through in the terminology video, so this particular system, we are going to call this as a distributed environment, because here we have more than one Kafka broker, so that the workload, whatever the data is coming into this particular cluster, is going to split into the multiple brokers. Okay, so let's not more focus on the terminology, because we already gone through the terminology. If you missed those videos, I highly recommend you watch the at least Kafka terminology video, so that you will get the sound knowledge of what is the terminology for the Kafka, and then you will get the core concepts to continue watching the deployment strategy. So here, for example, let's assume that in this particular single server we have the Kafka. So we have to understand one thing. So where we can use the single node architecture and where we can use the multi-node architecture. For the single node architecture, this is perfectly all right for doing some lab test, or if you are doing some sort of POC, which is like a proof of concept, there you can try the single node architecture. However, if you are running something serious on the production environment, or if you are doing something serious on the real environments, like the real E1, E2 environments, then it's a very highly recommend to use the multi-node architecture, because here, as we already gone through the terminology video. So if we go with the multi-node architecture, this is going to give the high availability, and it is going to do the fault tolerance. I mean, it is going to support the fault tolerance. Not only that, if you have the multiple Kafka brokers, all these brokers are going to share the workload. Okay, so that's the one of the key component we have to understand. The second one is we have to understand the components into the single node architecture and also multi-node architecture. So there is one component we have to understand very clearly, which is ZooKeeper. And the ZooKeeper, it should be the same in the single node architecture, and also here the ZooKeeper service is also same. The key difference here is since we have only the single server, within this single server, we are going to have the Kafka service and also the ZooKeeper service. We will talk about what is the purpose of the ZooKeeper in a minute, but for now, just stick with me. I will try to give you the conceptual idea what we are doing here with the ZooKeeper or something like that. Okay, so since we have only single server here, within the single server, we are going to have the Kafka service plus ZooKeeper here. When it comes to the multi-node architecture, here there are two possibilities. So here, since we have 3 servers, we can either run the ZooKeeper service into this particular environment, or we can provision some other servers, and these servers can serve as the ZooKeeper quorum. So here there are two possibilities. So the one possibility is we can combine all these ZooKeepers into these Kafka brokers, or we can also separate this particular ZooKeeper service into some other cluster, so that these ZooKeeper services can be running independent of the Kafka broker. So whatever the servers we have here, the sole purpose for these servers are like doing the Kafka broker activities. However, the servers whatever we are designating here for the Kafka ZooKeeper services, these ZooKeeper services will work as a single cluster. So here, this entire system will work as a multi-node Kafka cluster. So in the real life, we may have either 3 servers for 3 node Kafka brokers, or maybe we end up having the 6 servers, 3 servers for the Kafka brokers and the 3 servers for the ZooKeeper services. Now let's talk about what is the purpose of the ZooKeeper, right? So as we gone through in the terminology video, in every single Kafka broker, we are going to have the topics. Topics are nothing but those are split into the different partitions, right? So as we know, for every single partition, we are going to have the leader partition and the follower partition. So for the Kafka brokers, we will have the active broker and the follower brokers, right? So who is going to keep track of who's the active broker and who is going to track of what is the active leader partition, or who is going to track of the partition is up and running or partition is not available within the cluster, right? So that's where ZooKeeper is going to start working on tracking all these activities within the cluster. So I hope you understand what is the purpose of ZooKeeper here, right? So ZooKeeper is a open source software which can work as the quorum for any cluster. This is not just about the Kafka brokers, but we can also use the Apache ZooKeeper for variety of services. So in this particular scenario, we are going to use the ZooKeeper to keep track of what is the active Kafka broker, and also we are going to use the ZooKeeper to keep track of who's the active leader partition and who's the replica partition and who's the follower partition, something like that. So I hope you are very clear on this concept, right? So there is, when it comes to the functionality, there is no difference between the single ZooKeeper versus the multi-node ZooKeeper, but only difference here is if we lose this ZooKeeper service, what that means is that this entire cluster is down, because we don't have the replicas, we don't have some other followers ZooKeeper services. But when it comes to this particular multi-node architecture, even though I lost one ZooKeeper service, there are 2 other ZooKeeper services which can serve the quorum service for the entire cluster. Meaning, even though I lose one ZooKeeper server, still my cluster will work function as it is, because my other ZooKeepers are going to serve the needs for the cluster. And likewise here, since we have the 3 brokers within this cluster, even though this particular broker is not available, still my cluster is going to be up and running, and these 2 Kafka brokers are going to take the traffic from the end clients. Okay, so now we spoke about the single node architecture, multi-node architecture, and we spoke about the core components of the ZooKeeper here, and there is another component we need to talk about, which is Raft. So to be honest, this Raft is newly introduced into the Kafka environment. So as we just gone through the ZooKeeper, this is an open source ZooKeeper service, right? But when it comes to the Kafka Raft, this is nothing but the replacement for the Kafka services. I mean the ZooKeeper service. So Raft is nothing but this is also just sitting on the Kafka broker, and which will keep track of the same activities, whatever the performing by the ZooKeeper service. The whole idea of the introduction of the Raft service is eliminating the external dependencies with the ZooKeeper. So here in this particular example, if we need to provision the three node Kafka brokers, we end up provisioning the 6 servers, right? Because we are giving the 3 servers for the 3 brokers, and we are also giving the 3 dedicated servers for these ZooKeeper services, right? How about if we can include the Raft service, which is kind of embedded into the Kafka broker, then we can certainly eliminate another dependency, which is a ZooKeeper. So we don't have to provision the 3 servers. Not only that, this is going to eliminate the maintaining the external service, which is ZooKeeper into the cluster. So Raft is nothing but this is inbuilt Kafka component which will replace the ZooKeeper service. And when it comes to the functionality whatever performing by the ZooKeeper, those are fulfilling by the Kafka Raft service. service. Okay, so if we include the Kafka raft, now instead of calling this particular Kafka broker, now we are going to call this as a Kafka controller. With the introduction of the Kafka raft, so moving forward, we are going to call these as the Kafka controllers. So as we know, the sequencing for the Kafka brokers or the Kafka controller, that will start with a 0. So for example, if I have a 3-node cluster, then sequencing will be like a Kafka controller 0 here, and then this is a Kafka controller 1, and this is a Kafka controller 2. And now let's talk about the deployment strategy, right? So far we spoke about what is the single node architecture, multi-node architecture. Now it's time to understand the deployment architecture, meaning how we are going to do the deployment of these services, right? So in 2025, we really don't have to run that particular single node Kafka broker into the virtual machine or running on top of some physical server. So we can also run this single service onto the either podman environment, or we can also run this as a Docker container. So it's matter of executing one single command. So we are going move after this this particular video. We have some other section that is the deployment, and during the deployment we will talk about how we are going to spin up the single node Kafka, and during the time we may use either podman or Docker. But if we need to run the single Kafka broker, we can either run on the podman or Docker. When it comes to the multi-node architecture, so most of the companies are provisioning the Kafka cluster into the monolithic architecture, but it is also possible to spin up the same Kafka cluster running on top of the Kubernetes. So here, let's say if we need to provision the 3-node cluster, either we can provision the 3-node cluster using VMs or maybe the physical servers, or we can also provision the 3 servers, 3 Kafka controllers on Kubernetes too. So in this particular video series, instead of I more focus on deploying the Kafka into the VM architecture, we are going to provision the Kafka controller on top of the Kubernetes. And we are going to cover that installation in the installation video, but here I just like to cover the conceptual idea. So I hope the installation method is also very clear, right? So when it comes to the single node architecture, we can either deploy that single node architecture single node onto the podman, or we can deploy into the Docker environment, or if we really need to go back in the time, we can also deploy the same service running on the virtual machine. When it comes to the multi-node architecture, we can either deploy the Kafka cluster on top of the virtual machines, or we can deploy the Kafka environment onto the physical servers, or it is also possible to deploy the Kafka environment on top of the Kubernetes. So in this particular video series, we will more focus on how we are going to deploy the Kafka environment on top of the Kubernetes cluster. Most likely we will use the kind environment, and within the kind, maybe we will spin up 3-node Kafka broker environment, and then we will do some sort of testing, like writing some data into the Kafka environment, reading the data, and how we are going to see all those messages. Something like that we will do in the installation video. Okay, so far we spoke about the components within the Kafka environment. We spoke about the single node architecture, multi-node architecture. I just want to touch base on the messages flow, right? So for example, let's consider this is the Kafka environment. As we already gone through the terminology video, the message flow will look like something like this. So here we will have the producer, and this producer is going to write data into the Kafka environment, and on other side we are going to have the consumer, and this consumer is going to read the data from all the from the Kafka environment. So when I said the Kafka environment, this particular consumer is going to read the messages from the Kafka topics. So within the Kafka topics, as we know, we have partitions, and the Kafka consumer is going to read the messages from the partitions. Okay, so once we complete this video, in the next video we are going to talk about the producer internals, and also we are going to cover the Kafka consumer internals. So here we will discuss something like how the producer will work, like writing data into the Kafka environment, and on the other side, how consumers can read the messages into the read the messages from the Kafka environment. Okay, with that said, I hope I gave good clarity on this particular video. In the next video, let's talk about the producer internals and let's talk about the Kafka consumer internals. Thank you so much. I hope this video makes sense to you. If you like this video, please don't forget to subscribe and see you in the next video. Thank you.